This is the extra walkthrough of my reactor display program that was taken out of my episode 14 of the Daybreaker series. This, like I said in a previous episode when I just showed this was me figuring out how to use OpenComputer. I know a little bit of Lua, and I can look it up, anything I don't remember, because I don't use it very often. But yeah, this was just setting up some basic stuff to do this monitor. A few things you'll probably want to do is, if you're doing anything to the screen, you need to create, you don't have to create this variable GPU pointing to component GPU, but instead of typing component.gpu over and over again, by setting this up, you can just type GPU and it does the same thing. It's like a shortcut. I made a shortcut to component.mechanismMachine, which is what the name of the block over here, this guy down here, it's attached to one of the input ports on the side of the induction unit. And it sees the induction unit as a mechanism machine, which isn't very informative, but that's what it sees it as. And I know that's the power system, so I just say, give me the mechanism machine, I'm going to call that power. If there was more than one hooked up, I wouldn't know which one I'm getting if I did this command, because this is just asking for the default one. It picks one by default. I'm also telling it that we require events and require components. Obviously, they needed the component in order to get the mechanism machine, because it's coming off of component here. So I'm saying require the components library, and then give me the mechanism machine from that library. Here we're also asking for event, and that's just so that I can click on the screen and have the program stop cleanly. This is where I get the resolution of the screen currently and save it in these old width and old height. And then I set the resolution to 80 by 11, which is this screen size of the monitor. You can see right now it's only using like the middle chunk of the monitor from like here to here because it's the wrong shape. It will scale to fit the whatever, this is 3 blocks of monitor, it'll scale to fit whatever size monitor you have, but with black borders if it's not the right aspect ratio. So this sets the right aspect ratio and the right size for my display. I've created a function here called clear screen. So at any time I can write clear screen in my program and it will wipe the whole screen. And it does this by getting the background color, so it preserves it in old color, and then it restores that old color when it's done. That way when you call this function, it's not going to change your background color to something other than what you had it. If I had it orange, I want it to be orange when this is done. So this saves it and restores it. It's good practice. It gets the resolutions width and height, and then sets the background to 0. This is why I'm saving the background, because here I'm setting the background color to black, which is what 000 is. False just means I'm using the actual hex value and not an index to a limited set of colors. I want full access to all the colors, which you can do with a Tier 3 graphics card and Tier 3 monitor. So that's what the false is, just saying this is a hex number. And there's lots of tools on the web to let you select your color, and then it'll tell you what the hex value is. Basically, the first two, you have 0x just to say it's a hex number, and then each 2 pairs is red, green, and blue. But with all of them set to 0, then it's black. And then this tells it to fill from the first character on the first line to the last character on the last line with space. Now the space character, each of these letters has a background of black and a foreground of white. But space, doesn't matter what the foreground color is, it has no foreground pixels, it's blank. So it's just the black background color. So this fills it all in with the background color basically, and then restores the background color. So that's clear screen. This is where a lot of the work is. This is called progress bar. I made this. Give it a label, basically the line that you want to display this on, the current value, the max value, the color of the bar, and then some extra things here, which I'll explain in a moment. This is going to also save the color, but I don't think I restore the color, do I? Alright, well that's a mistake. Let's go ahead and fix that. GPU set background to old color false and indent that. So yeah, so this is again, I use the false here, which means that the old color is a hex value. So I'm saying use the hex value, and it is a hex value, and set it back. So that restores it the same way as the clear did. Just good practice. Alright, and here I'm setting the background color to 0. I am filling from the 3rd character on the chosen line, Y, to the 75th character, 2. Why is there a 2 there? Oh, this is 75 wide, and this is 2 high. So this goes down. If this was 1, then it would just be the 1 line that I'm filling in. 75 wide. It's not, yeah, it's width and height, not the absolute position. This is absolute position, the 3rd character of the yth line, but 75 characters wide, 2 characters high, make it all spaces. That's because we have the label on one line and the progress bar on the 2nd line. Width, I'm doing a math floor, which basically just truncates any remainder. So it basically rounds down to the lowest integer. And math is a whole library in Lua with lots of stuff in there, like sine and so forth. I'm just using the floor here. We're taking 75, which is the width of our bar, and dividing it by the max value. So that tells us how many segments are in there, and then multiplying it by the current value, and that tells us how many segments need to be filled in, and we truncate it because we can't draw half a space. And that gives us the width in characters for our bar. And then we take the width and we divide it by 75 to get it back into the original value, multiply by 100, and floor that, and that gives us a nice clean percentage value. So 0 to 100. And we're putting that in P for percentage. Now we're drawing on line, or 3 characters in, so I have a little bit of empty space on the left side of the monitor, on both sides of the monitor. On line Y, we're writing our label. This dot dot in Lua concatenates strings. So here I'm saying a label followed by a colon and a space, followed by, and this is format num P. This is our percentage. It really doesn't need the format num there. It could just be P. I'll explain what the format, actually, format num is really gone. I just should take that out. It just should be P. P, that is our number. Oh, no, wait. We do need something there. We'll call it toString P. I think that's correct, if I remember correctly. Because P is a number, and we're concatenating strings, so this will convert P to a string and add it into the list. And is that... I think that's right. Well, we'll find out when we run it. Let's quickly test. Save, write, auto run. Did I get that right? Yes, okay, because it's still writing out the 100. Click to end and back into up arrow gives you the history of everything you've typed recently. So get me back in here quickly. Alright, so yeah, toString turns the integer into a string, concatenates it, and then the percentage sign. So that writes our label line on the line Y. Here we set our background to a gray color. This is all 2s. Gives us a dark gray color. And then we fill in the 2nd line, Y plus 1, for the whole width with the spaces. And that fills in the gray line. That's a background of our progress bar. And then we set to our given color and do it just the width of our bar. So how much is currently filled in? We draw that in. and then restore the background color. Oh, I did have it here. Okay. Didn't even see it. Take that back out. It's unnecessary. We have it right here. Alright, now we get to these last two items, the show and unit. If show then. So show is coming in as a true or false value. And only if show was set to true, we're going to get a value string. So we have the value that we're passing in. So like how much power I've got, which is like 9 trillion. So the value, 9 trillion is coming in here. It's running a function called format big, which I wrote. It's farther down in the program. We'll get to that in a bit. We're giving the value into format big, which is a way to format a big number so that it looks nice on the screen. And it returns it as a string. And we concatenate it with unit, which could be blank, or it could be like RF, which is what this progress bar might be showing, is RF values. So it concatenates that in there. Then we get N, which is the string length. So string is another library in Lua. Len is short for length. It's asking for the length of whatever you pass in. I'm passing in the value string. That's returning me a number of characters in value string. And since I know that my display is, the progress bars are 75 wide, but they start 2 spaces in on the third character. So the total, they start 3 spaces in on the third character. So the total is 78 characters to the end of the progress bar. And we want to right justify this number, so we're taking that far edge, subtracting by the length of the string, and that's where we are writing the string in. On the same line, Y, as the label. And then it's done. That's the progress bar. Assign tanks is a bit odd, because we've got these 2 tanks up here, and you can see there's some redstone going on. Let's go behind the wall. Coming off the back of the top of the computer here, I've got some of this OpenComputer's cable, and it's going to this thing. Why is that there? Going to this thing, which is an adapter. OpenComputers has a number of different devices that it can recognize and read information from, but the adapter is to connect to things that are not part of OpenComputers. Vanilla stuff, other mods. So I'm connecting it here to a vanilla redstone comparator, which is attached to the gas tank. So this thing is putting out a signal between 0 and 15 based on how full the tank is. The tank is completely full, so it's putting out a signal of 15. This thing is reading it. And I've got 2 of them, one on each side, and I can't get over the ceilings too high. But there's another one down at the end of that cable on the other side. So we have 2 of these, both connected to comparators. Question is which? Come on, fly. Why can't I fly? There we go. And this was a problem I had when if I go down here, after all my function definitions, here's where I'm actually doing my program. I clear the screen, I start getting values for my energy values, I start printing out some labels on the screen, but at some point I need to get the tank. So here's tank 1, tank 2. I'm assigning tanks. That's what that function up there is. I don't know. I need to know that deuterium is tank 2 and tritium is tank 1. But the way they're coming in, I don't know that. Now, those adapters do have an address to them. That's a unique UUID string, a big long hex number thing. And they are unique, but it'd be a pain to have to type that in. So what this function does, this assign tanks, is it asks the component library for a list of all the comparators that it's connected to, and there's going to be 2. It has a function in it called getPrimary, where it picks one at random to be the main one. And it's not at random. It's based on something in the network. Maybe how far away it is on the cable. I don't know what it is. But it seems to be the same every time I start the system up again, or even restart the server. It's always picking the same one. If I changed how everything was wired together, that might also change. But for now, it seems to be always getting the same one. So that I'm calling as tank 1. But now I need tank 2. So I basically just loop through the list of all the tanks. I don't really need this print. You never see it because the screen gets cleared, but I'll take it out anyway. It loops through all the tanks, gets the proxy to one of those tanks, which component has a proxy function. It basically is just like the address, or it's a structure that holds the address and some other, and I think the name. And since I've assigned T1, I want to find the one that it is not T1. Of the 2 that are in the list, tanks has 2 tanks in it, and I've picked 1 for T1. To get T2, I loop through, I get whichever one it's pointing to right now, and I compare it to T1. So this is our temporary one that I've got here, and this is the T1, and I'm looking at T1's address is not equal to, that's tilde equals, not equal to, the temp's address. If that's true, then make temp into temp 2, or tank 2. Temp is tank 2. So we found our second tank because it's not our first tank. If temp address was equal to T1 address, then temp is the first tank, and that's not the one we want. So we go around to get the second one. Now I could just loop through and assign each one, like the first time I loop through, make that T1. Second time I loop through, T2. But I wanted to see if this getPrimary was reliable. So I'm doing it this way, and it's almost the same. So that assigns tank 1 and tank 2, and that's where I get them down here. So the next function I've got is the format big. Alright, this is where up here I wanted to print out the value of how much power I've got, you know, or how much power I can store. These are very large numbers. And if you try and print them out just in a print statement, you get it in exponential notation. You'll have an E and then a number at the end. It's not good for human reading. Great for computers, but not good for humans. So this is good for printing out for humans. So format big, you give it the value, which could be a very large number. And it basically is just going to loop through it, and it's going to take off 3 characters at a time. It's going to take off the 3 least significant digits, turn them into a string, add them to the end of another string with a comma, and just sort of keep doing that until it's got all the pieces. There's a couple little edge cases in here. You want to make sure that it's percent. If I'm using the string format, so the string library has a format output. This you have to go and look through how the format function works. I knew it from other languages because it's the same in a lot of different places like C. And that's the percent means this is a description of a chunk of string. The 3 is how many characters, and D is what sort of character, in this case, digits or numbers. The 0 in front of the 3 says if the number doesn't need 3 digits, like 12. 12 doesn't need 3 digits. But I want 3 digits for sure, so fill in the extras with zeros. So it'll be 0, 1, 2. So that's what that 0 is there for. So this takes that piece, pads it out to make it actually take 3 characters, That's in our output, and that's when the first time through here our output is empty. So we're writing the first least significant digits, the ones, tens, and hundreds digits. So we just write them out. If output is not empty and we still have parts remaining, because as I rip a piece off the value, I have the remainder of what's left. So if we still have more digits to go, or if we don't have any more digits to go, that's what this is saying. If the remainder is 0, then stick this part on with a comma and we're done. If there's still more stuff to go, and so it's not the first block of 3 and it's not the last block of 3, then format it with zeros and attach it with a comma. Because we want to have 3 digits in there. So right here with this, if it is the last piece of our puzzle, so it's the 98 in my 98 trillion, we don't want it to be 098. That's not how we write numbers. So we don't want to format it with that extra 0. So this one doesn't do the string format, it just writes out the part, which you can concatenate an integer and it'll figure it out that you want it as a string. So yeah, that builds it up from right to left, and when it's done, it returns it. There are a couple different ways to do this. I tried some that I found that other people had, and they didn't work very well for me. There may have just been differences in Lua, or maybe what they had didn't actually work. I don't know. But this worked. I just wrote my own. I had an older version. Yeah, here's one of the ones that I had that somebody else was using the regular expressions to loop it. But I just don't think Lua was working properly with these sort of recursive type regular expressions. So this didn't work. And I'm actually just going to take that out because I'm not using it anywhere anymore. I had that one spot I was using it. Hopefully there's no others. We'll find out if we try and run it and it fails. I'll either change those other ones to straight up string conversion or use my format big. Because the format big will work with small numbers too. It's just that it can handle big numbers. Alright, so those are all the functions. Now we're down here. This is where we actually are starting to run code. This calls all the functions. We call this clear screen. We're doing the math floor again. Power we set up at the top. So asking for the mechanism machine. So this is our big battery. And we're saying it has its own functions built into it. We're saying get max energy stored. Get energy stored. Multiplying by 0.4 to take it from joules to RF. Because it's going to give you values in joules, and I want to convert them to RF right here. So max and current are now RF. I'm writing out to the screen the reactor fuel reserves. That's up at the top of the screen on line 1. Down near the bottom, I've got the power output that I'm writing. This I have to change every time I change the injection rate. I come in here and change this number. Basically, each number of the injection rate that changes, if I go up by 1, then I have to add 2 million to this number. So it's easy to change. Here I get the total string, which is where I'm using my format big function with the max and adding RF to the end. That is the total that our battery can hold. I'm just getting that as a string, and I'm doing the right justification trick I did before to put it on the right hand side of the bar. Now we're doing a loop. It's going to be a permanent loop while true do. True will never be false. True is always true. So it's going to keep doing this. And to get out of it, we're going to use the event, which is, I also set up the event up here. This is where we're actually using it. Event pull, and I'm telling it touch. So basically when we click the screen, this is going to return the X and Y position of where we clicked. Now I don't care where we clicked, I just want to know whether we clicked or not. And it returns some other values, but I don't care about those. And the standard way to indicate that in Lua is to use underscore as a variable that you just don't care about. So it's assigning those values to underscore, and we're not looking at it. The X and Y, I'm looking at it to see if either one of them is not 0. If both of them are not 0. I'm doing X and Y, but really it could be X or Y. But if one of them is not 0, then both of them are not 0. Then goto. Oh, it hurts me to do that. I hate gotos. But this is the way it's often referred to. There are other ways, but this is easy for everyone to read in such a small program. In big programs, gotos are nasty, and they should be avoided and burned with fire till they are very dead. But I'm using it here. Goto, quit, end. End is just part of the if. So it's basically just goto, quit. And down here is colon, quit, colon. That's just a label. So when it hits this line, it jumps down here, outside the loop. So this ends the loop if you click on the screen. That's what those two lines do. Here I call the progress bar, and I write my deuterium with the tank 2 get output signal. Get output signal is the function on the comparator. So it gives me the value up to 15. So this is my current value, and that is the max value of 15. This is the color of the bar, which is fully red, FF. FF is the maximum value for this byte, and this byte is red. This byte is green, this byte is blue. And that is on line 2. Now we have tritium, which is on line 5. That's using tank 1's get output signal, also max 15. Here I'm using half green, all blue. That gives us a nice lighter blue color. Both of these, I don't want a value at the end. So false for displaying the total value, because the total value would be whatever the output signal is. It'll be a number between 0 and 15. And I don't care about that. So don't display it with no label. If I could put something in here, it wouldn't matter because it's not doing it anyway. Tritium and the deuterium are set up that way. Now we want the power display bar. So we're getting the current value is from the power unit, get the energy that's stored in it. We already have that, really. But we want to get it again. Because while this is looping, that's going to change. So if I just used this current up here, it's not going to change. So I've got to get it again down here. So basically repeating this line down here. So basically updating current. And then we're creating the progress bar power stored, giving it just a green value. Not all the way green, because all the way green is just too bright. I found I tend to like the slightly darker green. The full bright red is okay, but green I tone it down a little bit, so it's only BB. Here I do want it to display the actual value because it's useful, unlike these. And I want to space RF as its unit. And then we sleep. OS is one of the libraries that are built in. Sleep for 1/4 of a second. That's very important. Otherwise, this thing is just running way too much. You don't need it updated that fast. So this goes a little bit slower. And that's the end of the loop. It'll loop. Then when we have clicked the screen, it's going to quit. I set the resolution to the old resolution. I restore it back to the full size. I clear the screen again, and that's it. This last bit is not part of the program. That's just part of the editor. It doesn't change. So let's save, quit, or close. Type the first 2 letters, hit tab, hit return. There it is. It is working. Now I did mention that we are connected to this guy. The cables for this block run, well, not there. There it is. It runs all the way underneath and comes up by the second comparator, the one on this side. So the cable goes up and over, connects to that guy, and then goes down and round over to here. And that is a lot of talking about computer craft and explaining a program. Hopefully it helps some of you. For those of you that don't care about, not computer craft, I keep saying that, OpenComputer. For those of you who don't care about OpenComputer, you probably didn't stick through this whole thing, so you're not hearing me. For those of you that did, I hope it helps you. I'm willing to help out if you have some questions about using it. But while I can help you with Lua, and I probably will, there are better resources for learning Lua and figuring out what you need to do. I mean, Google's your friend. If you've done any programming, just go ahead and Google your questions, and you'll usually find answers that you need. If this extra walkthrough helped you out, please let me know in the comments, and feel free to you can like this video, but liking the episode 14 that it was extracted from would be even more convenient, because that's what everybody's going to see from the front page. So this is Nonsanity, signing out. Take care, be good, see you next time.